Global warming will bring about another ice age within the century. I'm sure you've noticed that as well. Ireland is nearly the same latitude as Labrador, Canada, but has higher average temperatures due to an ocean circulation that carries comparatively warm water from the Gulf of Mexico to northern Europe. This is the Gulf Stream, one of the natural phenomena with the greatest influence on the Earth's climate. For more than 50 years, climatologists have studied its operation to determine when global warming would block it, upsetting the climate of most of the world. New research published in the journal Science Advances has expanded our understanding of the subject. Climate change and the Gulf Stream are linked by the melting of ice in Greenland and other Arctic areas as a result of rising average temperatures. The more ice melts, the more fresh water accumulates in the northern Atlantic Ocean. This changes the dynamics of ocean currents, which are regulated by temperature and salinity differences, and has the potential to obstruct the Gulf Stream. We don't know when this will happen, but a recent study reveals that the Earth is approaching this point. It claims that there is a good likelihood that the process of blocking the current will be initiated this century, and that the related consequences have thus far been underestimated. Climate change and the Gulf Stream are related by the melting of ice in Greenland and other Arctic areas as average temperatures rise. As the ice melts, more fresh water collects in the northern Atlantic Ocean. This alters the dynamics of ocean currents, which are influenced by temperature and salinity variations, and has a potential to impede the Gulf Stream. We don't know when this will happen, but a recent study suggests that the Earth is getting close. It asserts that there is a good chance that the process of blocking the current will begin this century, and that the implications have so far been underestimated. If you recall the hard winters of the late 1970s and early 1980s, you may also recall that there was much debate in scientific circles at the time over whether the frigid winter conditions represented the start of a new ice age. In recent decades, such warnings have been eclipsed by the huge discussion over global warming and how civilization might deal with a scorching globe rather than a frozen one. Apparently, the fact that we are still in an interglacial phase, during which ice retreated to its polar strongholds only a few thousand years ago, appears to have been forgotten, possibly relying on the assumption that global warming might prove advantageous in at least one way, keeping the threat of another ice age at bay. But is this actually true? Is it feasible that the dramatic increase in temperature we are witnessing will speed the arrival of a new ice age? Alas, yes. A rising body of research suggests that, at least in the UK and Western Europe, there is a substantial chance that this will occur, and quickly. As you might expect, the problem is with the Gulf Stream, an ocean stream that transports warm water north from the Caribbean to bathe the United Kingdom and northwestern Europe. Strawberries thrive along the Norwegian coast thanks to the Gulf Stream and its related currents, but glaciers reach sea level in Greenland at similar latitudes. These same currents allow palms to thrive in Cornwall and Hebrides, yet across the water in Labrador, even the toughest and least productive flora struggles to live. Without the Gulf Stream, temperatures in the United Kingdom and Northwest Europe will be around 5 degrees Celsius lower, with winters as harsh as those during the so-called Little Ice Age in the 17th to 19th century. So everything is fine, right? Not exactly. When we look closely at the mechanism that powers a continual and beneficial circulation of this warm water flow, we get the impression that something is awry. Okay, just bear with me. Currents constantly circulate the water in the ocean. Tidal currents run close to the shore and are affected by the sun and moon. Surface currents are influenced by winds. Other much slower currents from the surface to the seafloor, known as thermohaline circulation, are caused by variations in ocean salinity and temperature. These currents are carried in a huge global conveyor belt, which includes the AMOC, or Atlantic Meridional Overturning Circulation. The Atlantic Ocean's AMOC moves water from north to south and back in a protracted cycle. This circulation provides warmth to various parts of the world, while also transporting nutrients required to maintain aquatic life. The circulation process begins when warm water near the surface flows to the poles, such as the Gulf Stream in the North Atlantic, where it cools and develops sea ice. As this ice forms, salt remains in the ocean water. Because of the high salt content, the water becomes denser, sinks, and travels southward in the depth below. Eventually, the water is drawn back up to the surface and warms up in a process known as upwelling, completing the cycle. All right, everyone, just a second before we begin. Make sure to join the Space-Time channel, and clicking the bell will help us develop higher quality items. The entire circulation cycle of the AMOC and the global conveyor belt is rather slow. A parcel, any given cubic meter, of water takes approximately 1,000 years to travel down the belt. So, to put it simply, this is the process that has kept Northern Europe's climate mild and largely consistent for the past 10,000 years. Has it always been like way? No, regrettably. We now have substantial evidence that the Gulf Stream underwent a significant slowdown around 13,000 years ago, plunging Northern Europe into a period of glacial cold known as the Younger Dryas. During that period, the current decreased, significantly causing temperatures in Northern Europe to plummet by up to 10 degrees Celsius. As a result, the majority of the United Kingdom became a bleak frozen wasteland for at least 1,300 years. This climatic anomaly was named after Dryas octopetala, a lovely white flower from the Rosaceae family that grows on the tundra. The analysis of the absence of its pollen, confirmed by ice core samples, revealed that something quite remarkable must have occurred in those places 13,000 years ago. The rapid apparition of a new glacial period, just as the Earth was recovering from the last ice age, must have had terrible effects for the entire animal world, not just humans. For example, before the deluge, the temperature in Siberia was moderate and considerably warmer than it is today, with huge grasslands and forests that supported big animals such as mammoths, woolly rhinos, cave lions, saber-toothed tigers, and many other species. However, all of these creatures vanished abruptly. Identifying the specific cause of this catastrophic loss is quite difficult. There are multiple suspects, and the evidence is compelling, but the final verdict is still a long way off. Until roughly 10 years ago, the theory of cosmic impact in the form of a comet nucleus disintegrating in the atmosphere was widely accepted. Although this explanation had the benefit of explaining the simultaneous extinction of megafauna in North America, it was extensively questioned and eventually supplanted by a much more terrestrial one. The theory that the Younger Dryas was precipitated by an irregular ocean circulation induced by the influx of colder, less salty water from melting ice deposits created during the just-ended glacial grew in popularity over time. Beginning in the 1960s, with the research of American oceanographer Henry Stommel, it was theorized that an excessive rise in the amount of fresh water from North America's rivers and glaciers in Greenland could obstruct the AMOC. Water from the continents dilutes the salty ocean water. In the North Atlantic, continental waters dilute those of the Gulf Stream. The idea regarding the AMOC blockage is that they do so in excess, the density difference that propels warm water from the Gulf of Mexico to northern Europe will be reduced. This idea also implies that this mechanism enforces the existence of a tipping point, a crucial threshold beyond which a system is disrupted, often abruptly, irreversibly, or both. At worst, this expression could be taken as a point of no return. But why should we be concerned that anything comparable to the Younger Dryas could occur again soon? The reason is that, in addition to all the other potential change factors, we are now dealing with global warming, which is causing the Arctic and Greenland ice to melt too much and too quickly, dumping fresh water into the ocean and diluting the salinity of the waters in the North Atlantic. This drop in salinity causes the water to become less thick and less likely to sink as it flows south from Greenland, avoiding America. Less sinking of cold water causes less push of warm water northward, resulting in a slowing of the Gulf Stream over decades. And this, folks, is not a prediction that may turn out to be incorrect, but a completely observed fact. Previous research using ocean surface temperatures have found that the Gulf Stream has slowed by 20% since 1950 and is now at its weakest in over a millennium. This issue has been known for some time, but scientists are now outlining it in greater detail. In 2023, a research conducted by the Institute of Mathematical Sciences in Copenhagen showed that the system may collapse between 2025 and 2095, with a 95% confidence level. You read that correctly. This dreadful event might occur in 2095, not in the distant future. According to the numerous scenarios presented by cutting-edge computational models, the impending climate shock will hit central northern Europe and the Arctic hardest. In Europe, we would experience unusually harsh winters just a few years after the Gulf Stream was disrupted, particularly in Scandinavia and the United Kingdom. Temperatures here could drop by 3 degrees Celsius per decade, while some sections of Norway could see temperature drops of more than 20 degrees Celsius. Precipitation would fall significantly as a result of the diminished heat and water vapor supply, and the Arctic ice sheet would stretch far south. These abrupt and unacceptable changes would precipitate the collapse of existing marine and terrestrial ecosystems, resulting in a catastrophic economic and social crisis on a continental scale. However, Europe would not be the only region affected. The Atlantic Ocean level would rise by 70 centimeters, engulfing many coastal cities in the United States as well. Rainfall in the Amazon jungle would radically shift, transforming it into grassland, while the southern hemisphere will become increasingly warmer. Overall, there are many unknowns concerning the impact such an event might have on a planet that is experiencing another equally obvious and quick transition, but in the opposite direction. Furthermore, the Arctic and Europe, which would suffer most severe consequences, are also two hotspots of present global warming and climate change, complicating projections even further. However, there is no doubt that we are discussing an event, the collapse of the Atlantic thermohaline circulation, that must be avoided at all costs, as the implications, according to all publications on the subject, would be disastrous. To accomplish this, we must aim to rapidly and dramatically reduce greenhouse gas emissions into the environment, particularly CO2. But at this point, who can guarantee that every effort we make to manipulate the environment will not backfire, sending us into an uncontrollable cycle of action and reaction? Once again, this demonstrates that global warming, for which we are solely responsible, is nothing more than a gigantic planetary experiment, the results of which we cannot foretell. Wallace Broecker, a specialist of ocean circulation at the Lamont Doherty Earth Observatory in New York, accurately articulated the issue when he stated that the climate is an angry beast and we are poking it with sticks. Let us pray that when it ultimately turns against us, its teeth don't match its rage.